Do octopuses dream? What their brains reveal about consciousness itself. There is a creature on this planet that may dream. It isn't a mammal. It has no spine. Its blood runs blue. And its brain is built in a way that barely resembles anything we understand. Most people assume dreaming belongs to complex, warm-blooded animals. Creatures with brains like ours. The octopus breaks that assumption completely. In labs around the world, scientists have filmed sleeping octopuses. And what they saw was hard to watch without feeling unsettled. The skin starts to ripple. Colors flash across the body. Yellow. Then a deep mottled brown. Then black and white stripes, the same pattern an octopus flashes when a predator is closing in. Its arms twitch. Its body curls. Then it goes still. The animal never wakes up. Never opens its eyes. Never reacts to anything outside its tank. There is no predator. No threat. No reason for camouflage. Something is happening only inside its nervous system. Here's where it gets interesting. In 2012, researchers identified two distinct sleep states in octopuses. A quiet phase and an active phase. The quiet phase is calm, pale, motionless. The active phase is different. Short, intense, full of color and motion. It closely resembles REM sleep, the stage in humans most linked to vivid dreaming. But to understand why this matters, you need to understand something stranger first. An octopus doesn't have one brain. It has a brain in its head. And it has neurons scattered through its arms. Roughly 2/3 of its 500 million neurons live outside the head entirely. Each arm can sense, decide, act. Cut off from the body, an arm can still move on its own for a while. So the octopus may not experience the world as one unified mind. It may be something closer to a loose alliance. Several minds, working together, gathered under a single skin. Which raises a strange question. If an octopus dreams, whose dream is it? The explanation should have ended there. It didn't. In 2021, neuroscientist Silvia Medeiros and her team studied the color patterns during active sleep more closely. What they found wasn't random noise. The colors followed sequences. Recognizable sequences. Patterns the octopus uses while awake, while hunting, while hiding, while defending itself. The animal appeared to be replaying its own life. Unconscious. Compressed. Looping. This is the same kind of evidence scientists use to argue mammals dream. A sleeping cat's paws twitch like it's running. A sleeping dog barks without sound. Scientists call this motor replay, old experiences, firing again, with no one steering. Now apply that logic to the octopus. A creature with no spine. No neocortex. An evolutionary path that split from ours over 500 million years ago. And somehow, it might be doing the same thing. But the real question isn't about sleep. It's about consciousness itself. For most of scientific history, consciousness was treated as a mammal problem. Big brains. Dense wiring. Structures shaped by hundreds of millions of years of vertebrate evolution. The octopus doesn't fit that story. It evolved complex thought. Problem solving. Memory. Possibly some flicker of inner experience. And it did it alone. Cephalopods and vertebrates split so long ago that their last common ancestor didn't even have a centralized brain. Which means whatever created something like dreaming in the octopus, evolution built it twice. Separately. Independently. From nothing. And that changes the entire picture. If inner experience can emerge from a brain this different, this alien, by our standards, then consciousness may not be a rare accident of vertebrate biology. It may be something nervous systems reach for. Again and again. Whenever they grow complex enough. Regardless of the blueprint. Then something even stranger comes into focus. Octopuses are solitary. Most species live only 1 to 2 years. They never meet their offspring. They build no social structures. No culture. No passed down knowledge. There was no obvious reason for evolution to give them anything like a dream. And yet, here it is. One explanation is simple. Active sleep might just maintain the brain. Consolidate memory. Clean up the nervous system overnight. Dreaming, in this view, wouldn't require any real experience. Just biological housekeeping. The same kind that happens during human REM sleep, whether or not we remember what we saw. But that explanation has a gap. Why would the brain replay specific behaviors? Hunting sequences. Defensive displays. Color patterns tied to real memories. Why not random static? Why something so structured? Science doesn't have a final answer. And that gap, that uncertainty, points to something enormous. We are standing next to one of the oldest unanswered questions in biology. Where does consciousness come from? And how many times has nature built it? What the octopus suggests, even without proof, is hard to shake. Somewhere, in a dark tank, in total stillness, an animal with blue blood and a fractured brain may be replaying its day. Fear. Pursuit. Escape. Alone. In silence. With nothing watching and no reason to perform. If that's true, dreaming isn't a privilege reserved for complex mammalian minds. It might be something closer to universal. A quiet signature of awareness. Appearing again and again across the tree of life, in shapes we are only beginning to notice. And if an octopus can dream, the question stops being about octopuses. It becomes about everything else around us. Quietly experiencing a world we never thought to ask about. Thanks for watching. If you enjoyed this, subscribe for more. See you in the next one.